How do we test the validity of restrictions? The method by which we test the validity of restrictions.
What was our question?
Identify some ways by which we can test some null hypotheses about restrictions. How do we do that?
You could do an F-test.
We can do a t-test, right? If we just had a single restriction, like a linear combination of the coefficients, we can do a t-test. We can do an F-test if we have a set of restrictions that we were interested in. Under the null hypothesis, the restriction is either exactly true or it's not. So even if the restriction is violated by a little bit, we would reject it. Maybe that's a little too stringent, because after all, there's a trade-off between bias and variance. We can make the variance of our estimator smaller if we're willing to impose a restriction that may be only a little bit wrong. So the mean square error test is constructed like an F, but the statement of the null is not as stringent. Under the null hypothesis of the garden variety F test, the restrictions are exactly true. Under the mean square error test, we compare the mean square error under the restricted and unrestricted specifications. The mean square error is a k by k matrix. But one of the things that we know is that if the restricted model is really bad, the ratio of the mean square error of the restricted model to the unrestricted model has an upper bound to it. It just doesn't grow forever. And so we can look at the non-centrality parameter doesn't grow forever when the restrictions are incorrect. And so although the mean square error is a matrix, we don't need to look at all k times k minus 1 over 2 entries in it. Instead, we look at the non-centrality statistic corresponding to the different chi-squares that we know how to construct for it. It's a non-centrality parameter. Yeah. We construct an estimate of the non-centrality parameter that we would get if the null hypothesis is true. The null hypothesis meaning that the two mean square errors are not much different from one another. Excuse me? The non-central F. Right. Right. Excuse me? You're testing a hypothesis about some restriction. What do you believe to be the degrees of freedom? In our garden variety F and chi-square tests and T, what are the degrees of freedom? Same here. So it would be the number of restrictions. Well, I'd have to look it up. Is there a typo? What page am I looking at?
It's a review of what exactly is the goal of the lambda? Do you have a choice of the denominator?
What?
Do you actually have a choice in the denominator?
Say that again? It's a little hard to hear.
You have a choice only for lambda.
Ah. Suppose you put the one above and you multiply it by 2. No, sorry. No, there's not a typo. Your estimate of lambda is going to be the one that's there. The second one is your estimate of lambda. And you can read your test, your lambda. I should have a different character here in the first line. Put 2 in the denominator. But the message is that we construct our F statistic in the traditional way. But we read the critical value out of an F table that has a non-centrality parameter of 1/2. When we do our garden variety F test, we read our critical values out of a central F table. If you happen to have in your pocket a table with a non-centrality parameter of 1/2, you would find that the critical value that cuts off 95% of the distribution out of a non-central F is bigger than the one that cuts it off for a central F. And so when you use the mean square error test, because we're reading critical values out of the table, you know, to the right, you don't reject as many null hypotheses. So you're not being as conservative. And the risk test is less conservative still. So you structure that statistic the same way as usual. But now you read the critical values out of a non-central F where you computed the non-centrality parameter from here. So for the mean square error test, you always read the critical values out of a non-central F where the non-centrality parameter is a half. For the risk test, you have to do some work. You have to figure out ds, which is the smallest root of the part in square brackets. You have to do all these computations and take the trace, and that tells you what non-central F to use. Hillary.
Sorry, so for the mean square error test, the test statistic is the F that you're reading from.
The observed statistic is constructed the conventional way, but the critical value that you use changes. It uses an what? You always read the critical values from an F table with a non-centrality parameter of a half. Always under the mean square error test. The non-centrality, the true non-centrality parameter might be less than a half, but it can never be bigger than a half. So by choosing to read it out of a table with a non-centrality parameter at half, we're being somewhat more liberal. We're giving ourselves as much opportunity as possible to not reject the null. Which test is my favorite? The final test. Next week. Next Wednesday. I mean, that's kind of like, what's your favorite color?
Everybody has a favorite color. Every econometric person has a favorite test. Come on, you two.
Any other questions? Did I go over it?
Yeah, and then the bronze. It's not on the board, so we just talk about it.
So that you can write it down and then you can memorize what I wrote on the board? It pops up in several different places in the web lecture notes. It's in your textbook and it's in that answer key for a final exam. How many times do I have to write it down?
Which place is your favorite?
What place? What place?
So, like, an example.
You couldn't memorize enough examples that I couldn't find another one.
That's not like your favorite one.
But you have the American Statistician article. You have 2 places in the web lecture notes. You have at least 1 derivation in your textbook. And you have a couple of answer keys to different things on the web. How many different ways? What difference does it make if I take the time to write with a marker on the board? Another, exactly the same thing all over again.